let's take a look at 11.4. In 11.4, we're going to look at something that's called the binomial theorem. And what the binomial theorem tells us how to do is how to expand a binomial raised to a certain exponent. So raised to some power. So if we're looking at, let's say, a plus b squared, at this point we know what to do. That means that we've got two of these a plus b's and we would just FOIL. The problem is, what would you do if there were three of them, meaning it was cubed, or fourth power, or fifth power? It gets really messy really fast. And we don't want to have to do FOIL over and over and over again. This is what the binomial theorem will help us figure out. So what the binomial theorem lets us do is, if we raise this a plus b to the nth power, it helps us find the coefficients and the variables on each term. So what we notice, if we kind of look at the pattern here, let's look at the a plus b cubed here first, is notice it starts out with the a cubed, and then it works its way down. Then it has an a squared, then an a to the first. Then notice in the last term there's no a's at all. While the b's, our second variable, do the reverse. They work their ways up. We start out with no b's, then one b, then two b's, then three b's. The problem would be, how do you get your coefficients, the numbers out in front? Well, what they came up with is something that's called Pascal's Triangle. It tells us, given our exponent, the Pascal's Triangle can tell us the coefficients. So if we're looking at the third power here, it would be this line of Pascal's Triangle would tell us the coefficients were 1, 3, 3, and 1. So you can't see the first coefficient, it was a 1, then a 3, 3, and then last one you can't see it, so it's a 1. So when we would look at the fourth power, we'd have 1, 2, 3, 4, 5 terms, and the coefficients of each of those 5 terms would be 1, 4, 6, 4, 1 in the correct order. The problem is, Pascal's triangle would be really hard to fill in if you had to go to a really large number. So we wouldn't really want to use this triangle nor make this triangle if we have a very large n. So that's our big problem. We don't want to make this Pascal's triangle all the time because it's just not practical.